All right, let me put this in full screen. I'll probably edit this part out too. So on your end, is it just it's just a full screen of the slides, right? Nothing else?
Oh, you mean like on the screen
Like
itself?
just
Yeah.
Zoom. I mean, it's just Zoom.
I can see your tabs open
Oh,
if
okay.
that's what you mean.
Okay. Yeah, that's what I mean. Yeah. All right, now?
Okay, yeah, it's good now.
All right, I'm gonna start. Hi, everyone. I'm Keith Represar, and on behalf of Team The Ranch, welcome to our presentation on our computer networks project. Alongside me are my teammates, Emmanuel Ikuma and Aaron Torres, and together we've spent the last several weeks digging into the network protocol behavior of Red Dead Redemption 2, specifically its online multiplayer mode, Red Dead Online. In the next 15 minutes or so, we'll walk you through why we picked this game, what we learned about how its networking actually works, and what our own Wireshark capture revealed once we finally got our hands dirty with real traffic. Let's get into it. Here's the roadmap for today. We'll start with why we picked Red Dead Online over other titles, then moving into the background research the three of us did on how the game's networking is architected before we ever open Wireshark. From there, Emmanuel is going to walk you through the actual capture he ran, including a couple of honest mistakes we made along the way, and what our captures showed us. We'll close out with our conclusions and what we each of us individually took away from the project. On the right, you can see a preview of the raw packet list from Emmanuel's capture, which we'll come back to in detail later. So why Red Dead Online? Honestly, the first reason is simple. Is a simple team buy-in. All three of us already like the game, and that enthusiasm matters over a multi-week period. But there's a real technical justification too. Red Dead Online blends a persistent open world with real-time multiplayer synchronization, matchmaking, and cloud-backed account services, which gives us several distinct categories of traffic to identify in a single capture instead of just one. We did seriously consider a competitive shooter since those are common choices for this kind of project. But we set that idea aside because shooter traffic tends to be dominated almost entirely by one thing, continuous position and aim updates, which make for a pretty narrow, repetitive capture. Red Dead Online, by contrast, mixes fast combat and chases with slower activities like trading, story missions, and menu navigation. So we expected a richer mix of message types to compare, and that exactly is what drove our choice. Bringing this all together, here are the four conclusions we've drawn so far. First, we think the hybrid client server and peer-to-peer design is a deliberate cost and scalability trade-off, not an oversight. Running every player's continuous position updates through a central server for a game with long tail active population years after relapse would be expensive to operate, so Rockstar keeps the expensive high volume gameplay sync peer to peer while retaining central control over the things that matter most, like accounts and anti-cheat. Second, that design has real user visible costs. It's why so much troubleshooting content exists around NAT and port forwarding, and it's a plausible contributor to the cheating and modding problems the community reports, since peer supplied state is inherently less trustworthy than a server authoritative design. Third, working working without a public spec fundamentally changes the analysis process. You build understanding from the outside in rather than reading documentation, which is arguably the core networking skill this project is meant to build. And fourth, the problem-specific port differences remind us that our findings describe the PC and Xbox clients we actually captured, not necessarily every platform RDR2 runs on. I'm gonna pass it on now.
Okay. Wait, can you go back to the first slide? The one right before? All right. Hello, this is Aaron. I want to give you some quick background before we get into the networking specifics. Red Dead Redemption 2 runs on Rockstar's proprietary Rage engine, which traces back to Rockstar's San Diego acquisition of Angel Studios in 2002. And it's powered basically every major Rockstar release since 2006, including both GTA 5 and GTA Online. The game launched on consoles in October 2018 and on PC about a year later, with Red Dead Online arriving in beta shortly after and becoming a full release in 2019. In terms of scale, sessions cap out around 32 players organized into posses up to 8, compared to how GTA Online is structured with its biker gangs and companies. And critically for our project, none of that online play happens without first talking to Rockstar's backend, which they call Rockstar Game Services, for authentication and matchmaking. That back end dependency is something we expected to see clearly in our chapter, and it turned out to be even more prominent than we thought. Next slide. One of the most important things our research uncovered is that Red Dead Online doesn't use one single networking model, it's a hybrid. Some traffic, like account authentication, matchmaking, session bookkeeping, cloud save, and anti-cheat verification, gets routed through Rockstar's own back-end infrastructure. But the real-time exchange of player and world state, once you're actually in a session, your position, your horse, your actions, travels directly between players' machines over peer-to-peer connections instead of through a central server. This is consistent with third-party troubleshooting guides for reducing lag in the game, which specifically describes it as splitting information between server-routed and peer-to-peer paths. For our capture strategy, this meant we should expect to see a small number of steady connections to Rockstar's own servers, as long connections to many different peer IP addresses once we're actually playing. Two more research findings shaped our capture strategy. First, because part of the traffic is peer-to-peer, your NAT type and open ports actually matter for gameplay quality. Community guides consistently recommend forwarding specific ports, and interestingly, those ports different by platform. Xbox, PlayStation, and PC each have their own port requirements, and PC doesn't even use a fixed range anymore. It negotiates dynamic ports. It's a good reminder that a single game title isn't necessarily one networking implementation across every platform. Second, Rockstar's own support page lists a long list of numerical error codes that only occur when the client can't reach Rockstar's backend service. That tells us something important. Even during peer-to-peer gameplay, the game is constantly checking in with the cloud. We expected that to show up as a periodic HTTPS traffic running alongside the peer-to-peer UDP gameplay traffic, and as you'll see, that back-end traffic turned out to be more constant than we expected it to be. This section covers what we could and couldn't find about the actual wire protocol. Unlike an older game like Quake 3 Arena, whose network protocol has been openly documented by outside developers, Red Dead Online has no official published spec. And Rockstar's own terms of service explicitly prohibit reverse engineering their engine and services. So, from day one, we knew our analysis would have to lean on empirical observation in Wireshark rather than reading a document. That said, we did find some indirect insight, independent reverse engineering of a fan-built framework called Rage MP found that low-level session registration is built on a modified version of RackNet, a well-known UDP game networking library, combined with an encrypted announce packet and a challenge response handshake. That predicts we'd see a connection handshake before steady gameplay traffic, plus small periodic keep alive packets, but we want to be upfront. Rage MP is a third-party project, not Rockstar's official code, so we treated this as a hypothesis to test against our own capture, not a confirmed fact. Since there's no official catalog for Red Dead Online, we built our own working framework based on how RackNet's derived. Hybrid client server and peer to games are generally structured. This became our checklist heading into the live capture. Things like the initial handshake, keep alive heartbeats, matchmaking traffic, the constant stream of entity and state synchronization for player position and world updates, discrete player actions like firing a weapon, HTTPS calls to the backend, optional voice chat, missions, and economic traffic, and finally, disconnect and session teardown message. The whole point of this slide is that it's a prediction, not a finding. We fully expect to refine and correct this list once we had our own capture in front of us. And as you're about to hear from Emmanuel, that's exactly what happened.
So going after how we started the capture, I actually wasn't able to just use Wirecap to capture it. I had to also use EtherCap to poison the connection between my router and other devices on the network. And with that, I was able to capture the packets and also see just what else I had, apart from just my Xbox on there. With the Wireshark, it's an open source tool on Kali Linux. And basically, it's like a magnifying glass to see everything going in and out of the network. And in Wireshark, you also have a tab that you can see the packet list and details and inspect individual packets. And I also sorted them out through like TCP, UDP, and the different lists. There was about 12 of them. They had another tab for conversions and endpoints. And I was able to see the stats, and I could see actually where specifically the IP is and where it's going to. But it doesn't exactly tell me what the player's IP is, but it gives me their ISP, which can give me a ballpark of where they are and where the data center is and where all the information's going. And then it also shows the protocol hierarchy, which is just a quick breakdown of how to cap or how the capture is. And it's TCP, TLS, and HTTP versus raw packets. And there wasn't too many raw packets, but we'll see that on the next slide. This is the live capture I ran. As you can see, there's over 1 million in just 30 minutes. I had to use the IP adder in Linux on the Wireshark because I had forgot to just specifically only capture Xbox, and it captured everything on my network. And the total file was about 542 megabytes. Yeah. And overall, in the game, most of the time, I didn't do any missions because there was something going on. And I was playing with a few friends, so kind of just ran around in free roam. Yeah. I did play blackjack though, but for whatever reason during my blackjack session, I kept getting kicked off before the hands could get played. Not too sure what that was about, but we can look closer on the next slide. This is the protocol hierarchy breakdown. 58.3% was UDP traffic overall, which is just the multiplayer workhorse, which is probably just me walking around, every interaction I did. I did a little hunting, didn't do any fishing though, but yeah, 54% was unidentified, which would be the custom gameplay, which might be things like that hunting and fishing, or the hunting and horse riding, more likely. The TCP was the matchmaking, which would probably be whenever I was playing a little blackjack, because I haven't played blackjack in a while. So, and the modern low latency transports was probably me switching servers. I think I had to switch servers about 6 times. Yeah, there was something going on. Not too sure about that. And then the TLS would more than likely just be the party that I was in. So that's outside the game, that's Xbox Live traffic. And yeah, I had to look at this one. I wasn't too sure about the BitTorrent. I did have a few of that, but they said it's probably just updates for the game. And yeah, and as you can see, it lists everything right here in well organized, filed out. And then we can look closer on the next slide. This is the backend. This is the backend traffic. And as you can see in the picture, it shows you the IP address of where it's coming from and where it's going to. And obviously, for address A, because I did, like I said, narrow down to Xbox only, it's only going to show the IP address for my Xbox. But for address B, it's going to show everything else, other ISPs, Microsoft, and Rockstar, obviously, and just any other traffic that was going around. And as you can see on the right side, I already put it out there. Almost everything landed on port 443, which is hypertext. Forgot what it was called. Keith, you want to help me out on that one real quick?
Uh, you may be more knowledgeable.
That's all right.
It's
We'll
all
cut
right.
this part out.
Yeah.
We'll cut this part out.
Okay, next slide.
No, wait, no, I got it. Just had to get back into it. I put oh shit, I forgot what it's called. We'll skip over that part too. Okay, on the right side, we have the IP addresses that belong to Microsoft Azure, and then we have the IP addresses that belong to Microsoft directly. Both are under Microsoft, but Microsoft Azure is a cloud-based database center. So I think that's where all the data and information goes, and it probably routes through there and goes somewhere else. I had 50 to 270 packets and 20 to 110 kilobytes transferred per host for each specific IP address. That was the range. Next slide. Well, as you can see in the picture on the left, all address originates from port 6672, which is obviously not a standard Windows service, because originally we did plan to play it on Windows, but I didn't have it installed, so I just ran it off Xbox instead. There was thousands of conversions, and everything ranged from 30 to 40,000 packets in 5 to 8 megabytes in 13 minutes. I had to go ahead and put it in Axe Gemini for some help, and it told me this matches classic P2P, which is as expected since I was playing an online multiplayer game, Red Dead Redemption. Next slide. So I did a few who is, and how I decided which one I would do is I decided I would just scroll up and down really fast and click on a random one and see what it gave me. So IP address 92233.966 was a Virgin Media Limited, which I looked it up because I had never heard of it. Is some guy's ISP, an opponent, and I figured based off the timestamp, it might be somebody who I got into a fight with whenever I joined because it was really early out. And I'm guessing I don't know what the data that was. I don't know what the data in the packet was since it's encrypted, but I could guess it was just me killing him. So the next IP was 177.238.17.141, which was cable mass telecommunications in Mexico. And then the handshakes did line up with whenever I was playing blackjack. So I think it was whenever I joined their party or their table that we connected because the table sessions are held outside of the actual server, as I just found out. And then finally, I had to scroll for this one. I couldn't just randomly find it. But 216.220.2110 was a Microsoft Corporation data center, which was likely just for the login or messaging traffic because it happened super early. I think before I even hopped in the server, maybe just whenever I was loading up the game, because I did start the packet capture really early. Next slide. Handshakes, header, and encrypted payloads. Like I said earlier, the data is encrypted, and obviously I don't have a Microsoft decryption key, so I can never know what the payload actually is. But looking at it, we can see kind of what and how big it is and how long it is. And the TCP header, which was readable, tells us the ports, the sequence, the numbers, and the flags. The TLS client tells us the destination and the domain, which is rockstargames.com. Once the handshake completes, the payload shifts to unreadable encrypted bytes. Some pattern in UDP and gameplay traffic. Headers readable. Hold on, cut that part out. The same pattern was in the UDP. Cut that part out too. My fault. The same pattern is in the UDP gameplay traffic. Next slide. predictions versus what we actually captured. Like as we predicted, we would capture the main three backend flags, the matchmaking, the peer-to-peer, gameplay, and HTTPS. UDP obviously dominated most of the packet volume as its active gameplay and needing to constantly be updated over and over again. The handshakes were steady for the most part, except for the few times that did get cut out, and those were in black and red. What did surprise us though was the HTTP traffic was larger than what we had originally predicted. We didn't think there would be that many. The matchmaking relay was smaller, but I'm guessing it's because once the match is made or once we're all on the same server, it doesn't need to update as much. The service calls did persist even past just logging in. I'm guessing they do some type of updating process to make sure that the account logged in doesn't, or like the ID doesn't change. Well, I guess it's more for like people who hack. It must be some type of what's the word? Oh, some type of anti-cheat. Next slide.
So, bringing this all together, here are the four conclusions we've drawn so far. First, we think the hybrid client server and peer-to-peer design is a deliberate cost and scalability trade-off, not an oversight. Running every player's continuous position updates through a central server for a game with a long, tall, active population years after release would be expensive to operate, so Rockstar keeps the expensive high-volume gameplay sync peer-to-peer while retaining central control over the things that matter most, like accounts and anti-cheat. Second, the design has real user visible costs. It's why so much troubleshooting content exists around NAT and port forwarding, and it's a plausible contributor to the cheating and modding problems the community reports, since peer supplied state is inherently less trustworthy than a server authoritative design. Third, working without a public spec fundamentally changes the analysis process. You build understanding from the outside in rather than reading documentation, which is arguably the core networking skill that this project is meant to build. And fourth, the problem-specific port differences remind us that our findings describe the PC and Xbox clients we actually captured, not necessarily every platform RDR2 runs on. Lessons that we learned. So we, as a group, we underestimated the lead time the capture phase was needed. By review time, we were too close to the deadline for a second attempt. Next time, to improve our findings, we will schedule the live capture early and split research roles more deliberately to avoid duplicated work. Someone else.
My big takeaway about the limits of our research done entirely from outside sources, like we've discussed, without having an internal documentation. A lot of what we wrote about RDR2's networking was inferred from the Rage MP that we talked about earlier, reverse engineering and third party troubleshooting guidance, not confirmed directly. And while some of it held up well against the manual's packages, some didn't, particularly how much backend traffic we showed up relative to what we expected. But this is as we thought it would be going forward. I want to treat these outside claims as hypothesis to test, flag clearly what's confirmed versus what is being tested on and what is believed to be the community's response and actuation to the game's networking, even though it's all just hearsay without having any actual physical proof.
And my takeaway was, like Keith said, because I think we could have definitely done more in the gameplay and in the packet captures, but I should have also not poisoned the whole entire network because that's probably what was messing up the Wireshark because it was coming from like every device on my Wi-Fi.
Okay. Thank you. Uh, Feel free to leave us any questions, and we'd love to hear them. Thank you for your time. Bye-bye. All right, now I just gotta save it.
Yeah. How long
Nailed
was
it.
that?
All right.
It might have been like 30 minutes.
30 minutes?